Good morning, everybody, and welcome to Continuous Nurturing Through the Data Platform Lifecycle. We're going to be talking today about how we go to and from the web and how we do that successfully. And we'll touch on some ways to do it the wrong way, just in case you're getting ready to do something like that. My name is Jeff Garbus. I'm the CEO of Soaring Eagle Data Solutions. I'm going to be your host for today. In this discussion, we'll be talking about some tool sets. If you are not using a tool to monitor what you're doing it the hard way. We'll talk about mechanisms for capacity planning. One of the things that you find when you start moving to the cloud is you have to choose an environment, just choose an environment size. This has to do with processing. It has to do with storage amount and storage speed. And it is very easy to overpurchase and pay a lot for that muffler. We'll also talk about the platform life cycle, total cost of ownership, and then we'll do a case study. We did a relatively large environment at Tampa General Hospital, and we'll ask them to weigh in on what we're doing. Again, my name is Jeff Garbus. I'm with Soaring Eagle Data Solutions. I've been working with SQL Server since version 4.01 running on OS 2. Obviously, you may not be using SQL, but a lot of our customers are. I've written about 20 books on this subject, working with SQL Server for a very long time. If you're interested in reaching me, you can scan the QR code at the bottom or simply shoot me an email. If I don't get back to your email within about a day, I didn't receive it, so please reach out again. Mike Boschetti is our contact over at TGH, Tampa General Hospital. He's going to be talking about the project we did for them. Mike, do you want to take a moment and introduce yourself?
Sure. Hello, I'm Mike Boschetti, Senior Database Administrator and Database Technical Team Lead at Tampa General Hospital. Just over 13 years and working with Soaring Eagle and SQL Governor for 6 years to assist in optimizing our environment.
Thank you. Now we have Jani Savolainen. He is the brains behind the AI that uses machine learning to find out what workloads look like, what they should be, and measures the before and after results. Jani, please say hello.
Yeah, greetings from Finland, the country of Sibelius, sauna, and sisu. And it's nice to be here with you guys.
So we are the SQL Governor partner in the US to implement their solution. We're also 24/7 operational database support. We are all on shore. We are all expert. We are great at performance tuning, scaling, warehousing, you name it. Would be very happy to talk to you about any needs you have. And if you've just kicked out somebody for incompetence, we're happy to step in. TGH. Mike, can you tell us a little bit about TGH and where we were when we got started with you and where you are now?
Yeah, sure, Jeff. In the 13 years I've been at TGH, we've seen substantial growth due to the acquisitions of various health organizations in the Tampa Bay area. Just to give a rough idea, when I started at the hospital, we had about 5,000 employees with an IT shop of about 120. By comparison, now the hospital has over 15,000 employees with an IT coming in at around 350 plus. And similarly, we've seen our SQL environment grow at a substantial rate. Currently, our DBA team administrates around 170 SQL instances and around 1,200 plus databases.
That's a pretty respectable number. And thank you, Mike.
Sure.
Jani, a little bit about SQL Governor, please.
Yeah, so SQL Governor, we are a software company from Finland, and we also have a subsidiary in Delaware, US. And we are artificial intelligence-driven, phenomena-based SQL Server capacity planning and performance optimization software. And we have several international patents on those software methods. And we have customer cases where we have reached the 50%, even 50% savings on TCO. So that's in a nutshell.
Thank you. So one of the reasons we got involved with SQL Governor is data sprawl, and have a great solution to identifying with the number of servers you've got, how many you should really have, and reducing your licensing and other costs. So let's dig into capacity planning. So I've mentioned before that what you really want to do is quantify what you have, what you need, and then subsequently validate that what you bought was what you paid for as well as what you need. A lot of folks have a mandate from their C-levels or sometimes the boards that just basically say, we want to be up in the cloud. We don't want to own hardware anymore. And that's people who've been doing this for 20 or 30 years and are tired of every 3 to 5 years going through the migrations, the upgrades, the hardware turnover, the hardware evolution, and having to deal with that. And cloud is a great way to simplify and take that out of the equation. The catch is we are promised via marketing that that's going to save us money, save us resources, and save us aggravation. The catch with that is we have found a lot of our customers going from on-prem up to a cloud, might be Azure, might be AWS, might be Google, might be private cloud, finding that the promises were not what they expected. They moved from Azure to AWS or AWS to Google or Google to Azure. Finally throw up their hands and say, this isn't working, and bring it back down. Our case here is that if you're going up and not getting the results you're looking for, the results you need, you may not be doing it right, or you may be doing it the hard way, or you may not be able to record the metrics appropriately. Lift and shift. Okay, this is what we got on-prem. It looks like picking from a menu of options over on the Azure or AWS level that we're going to get A, B, or C. Let's just pick it up, plop it over, plop being one of my technical words, and go from there. Now, one of the problems that I've seen with customers over on that side is that they'll pay for something and then not get what they're paying for and not be able to quantify it. For example, one of my favorite things that pops up a lot in both Azure and AWS is that people will pay for 80,000 IOPS and they will get data retrieval rates, random data retrieval rates, which are about 4 times worse than spinning disk. They won't understand why because they haven't been able to quantify it, and they just realize and understand that everything seems to be a lot slower, and we get brought in at that time. So what do? We pick up a tool and we start quantifying what's going on. Maybe it wasn't I/O, maybe it was CPU, maybe their queries are performing differently. We don't know. So lift and shift, I would describe as probably the riskiest approach to moving up to the cloud or even back from the cloud. I'd like to toss this over to Jani to talk about some of the other options.
Yeah, thank you, Jeff. And exactly as you said, the lift and shift, it has few basic problems there. For example, if you are kind of comparing apples to apples, for example, if you go from on-premises to the Azure cloud, you may select CPU that has in source environment 16 cores, and you maybe like to have it on target system 16 cores. But then the chipset speed is different on target, and there may be logical or physical cores. CPU cores to RAM ratio may vary. That affects the page size expectancy, that affects the IOPS, the throughput, the CPU, the RAM, all that stuff. So on my experience, even 30% overall degradation may happen on lift and shift. And also the data platform availability is quite often problematical, and there is a need to refactor the established base there. So what comes to manual right sizing based on telemetry snapshots, it's much better option, but it's not like a bulletproof even, because then you are missing trends and the seasonality of the database workloads. You may have 1 hour or 1 day snapshot there, but you're missing the weekly patterns, the weekend and on service time, service break patterns, and also the monthly and so forth patterns on the data. and trends as well, which is very important for the longer term capacity planning. So there are several problems in this manual right sizing, and it doesn't help a lot still for the TCO savings. Then there is third option. That is also what SQL governance software is doing. And that is AI-based right sizing and consolidation based on advanced time series analytics. Then you get close to 100%, 99 to 100% right-sized database workloads. And also, why is that? It's because you take the 1 to 3 months of data and you have all the seasonality characteristics and trends of that data. And then when you extrapolate that over 1, 2, 3 years, so forth, you can get the exact understanding of that workload. Also, you can consolidate the workloads. So then you are able to, with machine learning, kind of bin packing problem, solve that which workload don't go like this, but they go like this. So then you optimize and minimize the sleeping CPU cycles and so forth. So that's very important part of the AI-based capacity planning. And then you end up having up to 50% licensing and data platform cost savings on TCO level. So all those nuances really affect that capacity and performance a lot.
Yeah, and you hit upon two things which I thought were really interesting. One is seasonality. That's a hard thing to measure if you're not paying attention to it. And the other is, it says here, up to 100% right-sized. And we're going to mention shortly that if you're not 100% right-sized immediately, you will be shortly because we go through a cycle of measurement and management. Mike, did you want to add anything to this?
Well, yeah, actually, as a case in point, we were actually mandated to do a lift and shift a while back. An external team was brought on that moved the servers into a cloud environment. But unfortunately, the metrics they used did not yield a 1-to-1 performance ratio when it came to SQL performance. So suddenly we had the right size. And in our case, we had SQL Governor monitoring in place for at least a year. So this gave us some performance metrics to use to see what chipsets would actually yield the correct performance. And using this method, we were able to correct all the lift and shift problems as related to SQL servers.
I bet you saved a few bucks too.
Yeah, yes, substantially.
So from approaches, let's talk about life cycle. I've been teaching performance and tuning for 30 years, and one of the things that I try to emphasize with my students is that the performance and tuning isn't an end result. Performance and tuning is a continuous operation. The reason for that is, as Jani mentioned, things like seasonality, but workloads change, scale changes. In TGH's case, I don't know how many hospitals you've acquired since I got started, but there's been a large number. And as a result, utilization changes, scale changes, and we need to pay attention to these things. They affect our needs, they affect our bandwidth, they affect, the fact that we didn't have an index on this table before doesn't matter, but man, everything is getting really slow. Let's make the adjustment and fix it. So we go from we're okay to things are changing. And when things change and people call and complain, we always ask what changed, and the answer is always nothing. But something changed, and sometimes it's not application, sometimes it's not hardware, sometimes it's just workload. And we need to be able to not only figure out that it's workload, but we need to be able to quantify it. Jani, do you want to take over here for a little bit?
Yeah, thank you, Jeff. Exactly. So the data platform life cycle, it's basically a cyclic process. So it's recurring and cyclic, whatever the cycle is, like from 1 year to 5 years. And to get the optimal performance and availability in the beginning of the migration of data platform, transitioning to the cloud or renewal or anything like that. So there is an important step that is a pre-migration performance optimization. And what it basically means is that if you don't optimize your workloads before you're going to a migration phase, capacity planning and migration phase, it's like you get the problems out, but they also will be put in to a new environment, and that's a not optimal situation. So first, pre-migration optimization, then the next phase is capacity planning and migration. And this capacity planning, if you just lift and shift, you can lose even 50% of cost savings there. So the capacity planning is very important. What workloads to right size and which workloads needs to be consolidated on server, instance, and database level in most efficient way. So this is important. And then the next step is when the migration is done to check the capacity on before the migration workloads are compared to after the migration. All the KPIs on server, instance, and database levels. So you understand then that is there need to tune that environment. And that helps to minimize the downtime and improve the performance still. And then the continuous process, and this many times is something that is not done, but this is very important, especially in a platform where you constantly add new servers, instances, databases, and deprecate some of them from the environment. So in such case, you can do quarterly, monthly, or even weekly optimization of capacity and performance. So it's a continuum where you see and browse the exactly the current situation on your capacity, and then you make the optimizations on performance-wise, or even change the if needed, if something is being added to the workloads or degraded, so you are able to adjust them to the par. And this is the process where you can save more like 10% more on TCO on annual level.
Yeah, and I'd like to just sort of rehash 2 points that Jani made. One is that if you optimize before you move to the cloud, then you may be reducing your costs going up there, and you don't have to go through the attempt of reducing the costs and reducing the size of environment after the move. That's all very expensive, and honestly, the cloud vendors don't make it easy for you most of the time to come back down. And the final thing is just rehashing what Jani said that I already said, which was that this is a continuous operation. You go through the cycle, and whether you do it again monthly, quarterly, whatever, continuously, you pay attention to what the workloads are doing and have a tool to monitor that. Mike, can I bring you in on this one?
Sure, of course. In this cycle, as mentioned, optimization is a continual process. And as we DBAs know, it's an integral part of the system development lifecycle, and this fits squarely into the maintenance evaluation phases of that lifecycle. And while we do have excellent monitoring tools at the hospital, SQL Governor allows us to analyze performance at the IOPS level over as long time spans, so we can see these trends, like you guys were mentioning, that were not clear to us in the past. We can take advantage of server consolidation to undertake what-if scenarios and see how the server would have performed if it had a different chipset, while measuring cost and performance to ensure that we're getting the best option for the money the hospital pays.
Yeah, that's another great point. Being able to measure something over time is frequently absolutely critical to understanding a current performance issue. So let's talk about Tampa General in particular. We, Soaring Eagle, have been working with them, I guess, about 8 years. It seems like a heartbeat. And I remember my grandmother telling me that your life goes by in the blink of an eye, so pay attention. And the older I get, the smarter she is, or was, sadly. But long time with great time with Tampa General. We brought SQL Governor in a while ago, back when we started learning of the SQL spread there and wanted to get our arms around it. At this point, I'll turn it right back to you, Jani, if that's okay.
Yeah, thank you, Jeff. So, yeah, I think that it may be most logical if you would tell a bit about more, Mike, of your environment.
Sure. Yeah. We get to do, take a more proactive reaction to our servers and demands. Our SQL environment has been very stable. We rarely get taken by surprise. Nearly all issues we've had in recent years come from outside influences in the form of GPO changes, Active Directory changes, or servers being moved to different OUs, things of that nature. But as far as the SQL environment goes, and it's been for quite some time, I think it's very, very tight.
Cool. So let's talk about where we landed. Mike?
Where we landed?
Yeah, business benefits for TGH. What did you get out of this?
Well, there's a whole bunch. I mean, obviously be able to be proactive. We're not dependent on other outside influences. Hey, we're having an issue or thing. Usually we see an issue before our users ever do.
Isn't that the coolest thing ever?
Yeah, that's what I really like.
For a DBA anyway.
Yeah.
Sorry to interrupt.
No, that's okay. No, that was good.
Jani, anything you'd like to add to this?
Yeah, I can tell a bit about those KPIs we had. So as discussed, it's a continuous improvement. It's like a DBA always tries to make everything perfect, close to perfect, and sometimes it's more work, sometimes it's less work, but it's always something to do. So from 2021 to 24, we had, for example, this CPU slack that was decreased by 9% on all SQL servers, and it's quite good number taking in account that all the time there is appearing new servers. This basically means that you have certain baselines on, let's say, hard systems, less critical, and then like test systems and so forth. So you have different baselines on them, and the idea is to get as close to the par of the baselines on average CPU, peaking CPU, so forth, as possible. And this also relates to the total cost of ownership, because then you're able to save also the CPU cores the closer you are to the par on the workloads. And also the CPU congestion decreased significantly in 31% of all the SQL servers. So we got more nines on the CPU congestion, and CPU congestion, of course, can slow down servers and so forth. So it's important to have those numbers as good as possible, as excellent as possible. And then on Azure side, from 23 to 24 alone, the CPU slack decreased by 5% on SQL servers, and the CPU congestion decreased 32% of all the SQL servers. So those just a couple of more technical KPIs on the environment.
Yeah, and once again, Jani touched on one of my favorite topics, which is that as DBAs, we get into a tuning mode and we tune everything and it looks perfect until the next day, at which point something has changed and we need to take a look at it. And that word continuous improvement, continuous optimization, phrases actually are just really important things to me personally, as somebody who takes responsibility for performance as well as taking responsibility for operations. So I guess short version, summary. If you are going to be looking at your environment, it's important to have a tool to do that with. Otherwise, you're doing it the hard way, you're guessing, and if you don't have information over time, it's impossible to predict what's going to happen when a change happens, which is similar to a past change. It's hard to predict seasonality. It's hard to predict scalability. As you start looking at things like migrating to the cloud, you can do a lift and shift. Lots of people have done it. I think we have all spoken with CIOs who have done it and have said, it costs 2, 3, 4, 5 times what we were promised it would cost, at which point everybody's got their resumes up to date and wondering if they're going to have a job the next day. And that's not intended to sound as ominous as it does, but honestly, it's a really rough feeling when you do something that you've been asked to do and suddenly the costs go way up. So big fan of measuring, big fan of using tools, big fan of moving forward. At this point, I'd like to open this up to questions from the floor. We'll be looking for anything in the chat, any types of questions. And Devin, if you can open up the chat and pose the questions, we'll answer them.
Yeah, hi guys, this is JP from Mexico. Just nice to see you all. A great success story. I just have a quick question. Maybe I missed it, but dollar value over 6 years, how much has the customer saved, do you think?
We tried coming up with a number, and I think Mike was hesitant to give us one. Did you come up with one subsequently, Mike?
I
Tough
don't
question,
have
you
a
know.
specific
Tough
one.
crowd.
I can tell you, obviously, in an enterprise environment, I mean, any kind of difference like that is going to be substantial. In this case, it's quite substantial. I'd say probably around about a 40% savings as far as that goes. At the actual whole dollar amount, I probably have not been entirely privy to that information.
That's okay, but the thing is 40% savings in terms of footprint, consolidation of servers, downsizing licenses, that kind of stuff, storage.
Effectively, yes. I mean, you're going to be able to right size. We basically can right size servers. So if we're over processing, we're able to identify that and then go ahead and take action to reduce the resources.
Great.
And thanks for the question, JP.
Yeah, thanks, Jeff. Good to see you. Good to see you, Jani. Right.
Thanks.
Here's one question for you, Jeff and company. In a short description, what would be the major differences in using these techniques and tools to analyze an on-prem environment versus the cloud environment that you're discussing in this case study?
Jani, do you want to take this one or do you want me to?
Yeah, I can take that. So if you mean the telemetric data behind, so of course the Azure environment, you get all the telemetry data from the IaaS VMs and the managed instances, just as you get that from the on-premises environment. And one of the biggest maybe differences is that for example, on IaaS, there is certain t-shirt sizes for each VM, and there are their own prerequisites and nuances on those VMs. So there is a need to know all these nuances. And for example, in SQL Governor software, they are all kept up to date, matching the computational power. But there is not that much really in terms of calculating the workloads. Like whether it's, let's say, VMware workload or Nutanix workload, there is, of course, clustered virtual machine reserve and so forth that our software support as well. But I would say that it's very similar mathematics, what happens there in between the private cloud to public cloud and so forth.
Yeah, and I'll just add that there are people like Jani who understand the hardware layer. I'm not one of them. I'm a straight database geek. So when I look at it, we got a few basic metrics, right? CPU, does it meet needs? Are we exceeding needs? Are we short? Disk, meet, exceed, short. Network, meet, exceed, short. And as we're looking at these things, I don't care whether you're in the cloud. I don't care whether you're on Azure, AWS, Google. I don't care if you're on-prem. You're either getting memory as fast as you need it. You're getting you're getting data off the hardware, the storage as fast as you need. I keep calling it disk, even though most people are using solid state these days. I think that just belies my age. But you either get it or you don't. But if you don't get it, if you're not getting what you need to be able to go back to the hardware people and say, okay, this is the metric I'm seeing. This is what I need. This is what I'm not getting. And having a tool like this lets me go back to the SAN people and say, you know what? I expect from my storage, if I've got enterprise class spinning disk, I get about a 5 millisecond disk retrieval speed, random page retrieval speed. If I'm going after flash storage, it's 0.5 milliseconds down to about 0.1 milliseconds. And what I'm seeing here is that I'm getting 50 or 60 milliseconds. And these are real numbers that I've pulled from going up to the cloud. And if I just say everything is slow, what ends up happening is I say, well, we're paying for 80,000 IOPS. And I need to tell them, well, you're not getting it. And they ask, well, how do I talk to the vendor about this? And without having the metrics, you simply can't get there from here. Now, from a database perspective, again, just picking that one metric, do I care how fast the data is coming off the disk? Only if it's not coming off as fast as I need it. So I will look at one metric that says how backed up is the IO. And unless the IO is backed up, I won't go look at the IO metric because I don't care. But intellectually, if the I/O is backed up, I look at the I/O speed. If the I/O speed's not where I need it, then the question becomes, well, it's slow today. Was it slow yesterday? Was it slow last week? Was it slow the week before? What changed? We did a hardware migration. Is that where this happened? We did a firmware upgrade. Is this where that happened? Because I've seen firmware upgrades cause bugs in data access. So without the monitoring, without the software, without that type of metric, you're simply out of luck and you're guessing. And you get in these war rooms where everybody's pointing the finger, and without having a graph in front of you, it's hard to say it's this.
Yeah, and I would like to add up also that things like, for example, as CPU contention or thread pool starvation or such phenomena, when you are able to identify those issues and also able to predict those probability of those issues when you're changing the chipset or changing the t-shirt size on IS, as I call the SQIs and so forth. So it helps a lot. And of course, there's on public cloud, of course, there is a lot of difference in storage performance on the different tiers. So that is very important when planning the workloads as well. Yeah.
And in fact, I'm going to put you on the spot, Mike, and I'm going to ask a question that I haven't asked you before, and I only hope I know the answer. And that is, we've been working together for 8 years. Have we ever been in a situation where we had to put everybody in a room to try to figure out where the performance problem was? Or do we always have the ability to tell you what the root cause is and say, this is where we need to go?
I think we have not even run into the situation where we're having performance problems that get taken by surprise for it. Usually we're already seeing that way ahead of time. And like in some of the cases, like especially where we're able to go ahead and collect data over the long term. I mean, even a minute change over the course of a year or two, which might be small, but still allows us to see what that trend is actually doing.
So no war room over at TGH. That's awesome. IT war room.
Not so far. No.
I'll knock on wood. Thank you. Do we have any other questions?
Don't think so.
Cool. All right, then we're going to end this. If anybody would like to get a demo of the SQL Governor product or talk to us, Devin's going to put a link in the chat. You can click on that. We'll also be putting this up for anybody who would like to see it again or share it with their friends or push it up the food chain to management who is asking you to do these things and are looking for a better approach. Thank you very much. Have a wonderful day.
Thank you very much.
Thanks, guys. Bye-bye.
Take care.
Bye-bye.